Yeah,
Right.
I want to see it.
Me too.
Let's go. So, with this one here, okay, what's the first thing you should always do? Draw a graph, right? Now, can somebody remind me, when I have a coefficient inside the function, what's that actually going to affect?
Period.
Right, okay, so I know that it's going to affect the period. In what way though? And again, this is a matter of whether you're okay with just memorizing things, or you work out, okay, usually the period is 2 pi, but for sine, the period, or t, is equal to 2 pi over b, where b is the coefficient of your x, which is just
2.
Yeah. So that's just going to be 2 pi over 2, or just pi. So that means that you should see one iteration of your sine wave every distance of pi. So you can just remember that as, okay, if it's sine of 2x, I should see the graph repeat twice in the usual period. Right? It's twice as fast. You just remember it like that. Okay. So I'm going from pi to pi, but instead now I'm going to see the graph twice. 1, 2.
That's a big.
What are these other values going to be?
We'll have 2 pi on 2
Pi on
there.
2.
And 3 pi on 2.
Okay. Alright.
But that other one doesn't really matter to us.
Yeah, right, because the question is actually not asking for those values, it's asking for the y-axis, which is the usual one, and also x equals to pi on 4 to x equals to pi on 2. So I know that x equals to pi on 2 is here.
And then pi on 4 comes halfway in between.
Yeah, it would just be halfway, wouldn't it? Right. Because halfway between 0 and pi on 2. That makes it really easy, doesn't it? I know that my whole area is now above the axis, or it's positive, right? So I don't need to do any absolute values. So now I'm setting up my integral. I've got the integral from pi on 4 to pi on 2, sine of 2x dx. Okay. Now, what do I have to be careful of with this integral though?
There's 2 there.
Yeah, so you remember, if there's a coefficient inside the function, you have to take it outside and put it on the denominator. Put it on the denominator, right, okay. So in this case, the integral side is usually just negative cos, but here I've got to be careful of that coefficient there.
Negative 1 on 2.
Yeah, negative 1 on 2 cos, but I keep the original function the same, 2 of x. Right, now remember, I'm applying the integral, so what I do with my brackets, I put the square brackets in, right?
And you chuck those numbers onto the bound.
Yeah, and then I keep my bounds here. Now, a better way to actually do this, because the negatives can get quite confusing, what you could do is you could actually just take the negative out. If you take the negative out, you don't have to deal with it, you don't have to apply it at the end. And because there's no absolute values or anything, it's not going to get messy at all. I'm just going to take that negative 1 out. I just have half cos 2x, pi on 2, 4. Okay. And again, I'm just going to substitute in my x values here. So I'm going to have negative. Actually, I could take out the half as well, couldn't I? Yeah, I can actually take out the half as well, just to make things easier, right? Negative half. Yeah. Okay. So this first one here, I'm going to substitute in that as my x value. So cos of 2 times pi on 2 minus cos of 2 times pi on 4. Well, that's actually just going to simplify quite nicely, isn't it?
Isn't that pi on 2 0?
This one here.
Yeah, well, like after.
Yeah. So I'm just gonna simplify it out first.
Yeah, so
That'll just be cos of just pi minus cos of, what's this going to be? Cos of, what's 2 pi on 4? That's just
0.
pi on 2, right?
Yeah.
0.
0. Totally 0.
Yeah. I don't apply the absolute value just yet. I still want you getting the hang of just doing this, right? And the reason is because you may simplify it incorrectly in your head, right? So just write out all the steps. And now we can easily find what these exact values would be. I'm just going to draw my graph again. Okay. So what's cos of pi? That's
Negative 1.
negative 1. And then cos of
0.
pi on 2? Yeah, 0, right?
So
Minus
you know
0.
you took the negative half out?
Yep.
Do you have to do that?
You don't have to, but remember how the problem we encountered in the first question, it got really messy when we're doing all these negatives of negatives, right? An easy way to do it is if you just take out any constants when you do this integration, because constants don't affect anything, right? We can actually take it out and we can deal with it later.
Seconds a half.
Yeah, and it makes the question a lot easier. And here, you just got negative half times negative 1, which is just half this squared. Okay. Any questions about that one?
No, sorry.
Yeah,
Can't see,
okay.
that's why.